The following video is a video over 1-2 notes, and this is titled Linear Measure. I want to first talk about the root word of linear, which is line. So we're going to be talking about lines. The first thing I want to talk about is a line segment. Okay, and a line segment is a line with endpoints. Okay. Okay, so that's what a line segment is. So what I want to do real quick is talk about how we actually measure lines and stuff like that. So first I want to just draw a generic line here, and I'm going to call that line segment AB. Okay, line segment AB. Okay, and if I were to name this, I would call it AB. All right, with a little line up top. If I'm talking about a line segment, there are no arrows at the top, just a single line. And what I'm going to say about AB is that AB has a length of 4 inches. Okay, so I'm going to go over here and say that AB is 4 inches. Okay. The next thing I'm going to do is I'm going to say that there is a point C that is in between A and B. I'm going to call that point C. Okay. And what I know about segment length, now I have a segment that I'll call AC, okay, which is a part of the segment of the bigger segment. And I'm going to say that AC is equal to 1 inch, okay, so I'm going to label that here, that this is 1 inch. So the question is, what's the length of CB, okay? What is that length, okay? I'm going to call that X, all right? And if you think about it, okay, if the whole thing from A to B is 4 inches, okay, and that's kind of how I denote the length of an entire thing, and this segment is 1 inch, then what's the length of CB? Okay, well, let's think about it, all right? If I took the length of 1 inch and added an unknown distance, which is X, and it equals 4 inches, because the whole thing is 4 inches, then what I could do is I kind of just know, I can solve this equation, and I can just subtract 1 from both sides, and I get that X is equal to 3. Okay, so I'm going to call this 3 inches. Okay, so CB is equal to 3 inches, okay? And we'll do an activity in class where we really try and reinforce this idea. And so here's what we've got, okay? We have this mathematical statement here that, and I'm going to call this the, I'm going to do this. I'm going to say 1 plus 3 is equal to 4. Okay, this is a true statement, and all it says that 1 inch plus 3 inches is equal to a total of 4 inches. Okay, well, let me replace 1 with the segment that we called it. Okay, and we called that AC. Okay, so if I take segment length AC and add it to some segment that's 3 inches, well, instead of writing 3 inches, I'm going to write CB. Okay, and then the segment that's 4 inches, we called that segment AB. Okay, and so what I have here, guys, is that I call this the segment addition postulate. Okay, segment addition postulate. All right, postulate. And I call it the segment addition postulate because we're adding segments together. Okay. And basically what it means is that 2 smaller segments make a big segment. 2 small segments make a big segment. All right? And so this is something that we're going to do all year long. And what we know, in order for this to work, is we have the initial prompt that C is between A and B. Okay, so if C is between A and B, then we can make this conclusion. Okay, one other thing that I do want to talk about here is this vocab word called congruent segments. Congruent segments. Okay. And congruent segments are line segments with the same measure. Okay, line segments with the same measure. Okay, so let's kind of jump in here, and we're going to do some more of this tomorrow and actually measure line segments. But if I wanted to find the length of this line segment, I want to take a ruler here, start this at 0, and these are each centimeter. So I've got 1 centimeter, 2 centimeters, 3 centimeters, 4 centimeters, 5 centimeters, and then I've got 5 of these little tick marks. So there are a total of 10. Okay, so I would say that this length is 5.5 centimeters, or 5.5 centimeters. Okay, we'll talk about measuring lines a lot in class. Okay, so let's kind of take a look at what's going on here. What it wants us to do here is find the measurement. So find the length from point N to point Q if QP is 1 inch and PN is 1 1/4 inches. So what I want to do here is I'm going to set up the segment addition postulate. If I take segment length QP and I add it to PN, then I get a total length of NQ. It gives me the entire segment. Well, I'm going to plug in the values of, what I've got. I know that QP is 1. I know that PN is 1 1/4. I'm going to change that to 1.25. And that's the total length of NQ, okay? So if I take 1 plus 1.125, then I get 2.25. And that's going to give me the segment length of NQ, and this is in inches. Okay, so pretty simple. All right, let's take a look at number 3. Number 3 says we want to find GH. Okay, so I don't have a length for GH. I'm going to just go ahead and call this X. Okay, and by the segment addition postulate, I know this. I know that FG plus GH, which is what we're trying to find, is equal to FH, the whole thing, okay? So I set this up every time just so I set everything else up right, okay? And so FG is the value of 9.7 plus the value of GH, which I'm just going to call that X for right now, and I'm going to set that equal to 15, okay? So if I solve this equation for X, I'm going to subtract 9.7 from both sides, okay? And I end up getting a value for X that is 5.3. Okay, so we need to answer the question, what's the length of GH? So GH is equal to 5.3 millimeters, okay? So it's important that we label that when we answer the question. So GH is equal to 5.3 millimeters. All right, let's take a look at number 4, okay? Now, it doesn't give us a picture, okay, but it says find the value of X and YZ, okay, if Y is between X and Z. So guys, this follows the same thing that we just had, okay? So I'm going to draw a generic line, okay? I'm going to give it endpoints of X and Z. So I'm going to call this length X, or point X, I'm sorry, and this point Z. And I know that Y is somewhere in between those two. So anywhere in between here, I'm going to put another point, and I'm going to call it Y, okay? And it wants us to find the value of X and find the value of YZ. So I'm going to find this length here. Now, my drawing is probably not going to be to scale, but it helps us visualize what we're doing and helps us set up the equation that we need to use to solve. So for XY, that value is 5X. Okay, for YZ, I'm going to call that X. And XY, the whole thing, is 25. Okay? So what we're going to do is we're going to set up an equation. I know that xy plus yz is equal to xz, okay? So xy, that's 5x, plus yz, which is just x, gives me a total length of 25, okay? So I'm going to combine my like terms here because my whole objective here is to solve for x, and so I get a length of 6x is equal to 25, okay? I'm going to divide by 6 and divide by 6, and I get a value of x that's equal to 25 sixths. Okay, and that's a number. Okay, so what I want to do is I found x, so also wants me to find yz. Well, yz is x. So yz, since that's equal to x, I'm just going to plug in 25 sixths, and that's it. Okay, and that's the length of yz. All right. So now let's take a look over at number 5. We have the same scenario. So I'm going to draw the same generic picture. Okay, and you guys should all be drawing these pictures because it really helps you visualize what's going on. Okay, so I've got x is an endpoint and z is an endpoint, and I know that point y is somewhere in the middle. Okay, now it tells me that xz is 28. I'm going to call this whole thing 28. All right, I know that xy is 12. Okay, and I know that yz is 2x. Okay, so I know this by the segment addition postulate: xy, that length, plus yz. Okay, hold on. xy, that length, plus yz, this other length, gives me the total length, xz. Okay? So xy, I'm going to substitute in 12 for that. For yz, I'm going to substitute in 2x. And for xz, I'm going to substitute in 28. Okay? Now I'm going to solve for x. So if I subtract 12 from both sides, then I'm going to end up getting 2x is equal to, what is that, 16? Okay, I'm going to divide by 2 on both sides, divide by 2, and so I get x is equal to 8. So I found x. Okay, but the question wants me to find also yz. Well, yz in this scenario was equal to 2 times x. Well, I don't want to write x. I'm going to write 8 instead of x. I plug that in. And so I end up getting the value that yz is equal to 16. Okay? So these are very, very standard geometry problems, guys. They're pretty easy to get through. Let's take a quick look at number 6 and 7. And so on 6, it says determine whether each pair of segments is congruent. Okay, so it gives me segment BE, and that's this segment right here, and I know that that length is 3 meters, and then CD is also 3 meters. Okay, so because those have the same measure, because they're both 3 meters, I can say that BE is congruent, and this is the symbol for congruent. It's an equal sign with a little tilde up top. All right. And then I can say that BE is congruent to CD, okay? And it's because they have the same measure, because they're both equal to 3, okay? Now, NP and NP, all right? So MP is 12 yards, and then NP is 10 yards. Are these the same number? No, okay? So I would say that NP, segment NP, is not congruent, and if I would write, if I'm saying not congruent, I make the congruent symbol, and I put a slash through it, it's not congruent to NP, okay? And it's because they don't have the same measure, all right? So I hope this helps with the homework. Please get started on it. Thank you.